Alright, let's go ahead and take a look at these problems. These problems involve the inverse cosine, so let's talk just real quick about those properties. Recall the inverse cosine's domain is -1 to 1, including -1 and 1. Its outputs, or its range, are between 0 and pi, including 0 and pi. The operation that inverse cosine performs is it takes and looks at the x-coordinate of a terminal point corresponding to a real number between 0 and pi, and it outputs for us whatever that real number is. So let's go ahead and start with the inverse cosine of -√2/2. So again, we need to find the real number between 0 and pi that corresponds to the terminal point with the x-coordinate -√2/2. And you might think to yourselves, well, I know some real number. Consider the real number 3 pi fourths. And this real number corresponds to the terminal point -√2/2, comma √2/2. So what real number corresponds, real number between 0 and pi has a terminal point with the x-coordinate -√2/2? Well, this point 3 pi fourths. So we can say that the inverse cosine of -√2/2 is equal to 3 pi fourths. Let's go ahead and look at part B, the cosine of the inverse cosine of 1/2. So again, same sort of comment with compositions of trig functions and inverse trig functions. Let's go ahead and evaluate first the inverse cosine of 1/2. So the inverse cosine of 1/2, we could think to ourselves, well, on the unit circle, the real number pi thirds corresponds to a terminal point whose x-coordinate is √3/2. Therefore, the inverse cosine of 1/2 must be equal to pi thirds. And then we can evaluate the cosine of pi thirds, noting that's just the x-coordinate of the terminal point corresponding to pi thirds, which is 1/2. So we can see here that we have the cosine of the inverse cosine of 1/2 is equal to 1/2. So let's go ahead and do part C and D, and then we'll write up those theorems that we could write if we wanted to memorize when compositions of cosine and inverse cosine cancel and when they don't. You can see in this case, it was a case where we had our input equal to our output. Let's look at C. So if I evaluate here, first the cosine of pi halves is just, this is just going to be equal to, at pi halves, the terminal point is 0, 1. The x-coordinate is 0, so we're looking at the inverse cosine of 0. The inverse cosine of 0, we need to find some real number between 0 and pi whose terminal point has an x-coordinate equal to 0. And again, note that's that value we just saw here at pi halves. So the real number pi halves corresponds to the terminal point 0, 1, whose x-coordinate is 0. So we find the evaluation here is pi halves. So we can see the inverse cosine of the cosine of pi halves is equal to pi halves. Let's go ahead and check out part D, the inverse cosine of 3 pi halves. Well, we know 3 pi halves has the terminal point -1, 0, or sorry, excuse me, 0, -1, right? So 3 pi halves corresponds to this terminal point, 0, -1. Its x-coordinate is 0, so we're looking for the inverse cosine of 0. See that we've already evaluated the inverse cosine of 0, it's pi halves. So we can say that the inverse cosine of the cosine of 3 pi halves is equal to pi halves. And we've seen this last case where our input is not equal to our output. So what we can say here, a couple of theorems if we wanted to. First, that the cosine of the inverse cosine of x equals x for all x within the domain of inverse cosine. We can say that the inverse cosine of the cosine of x equals x for all x within the range of inverse cosine, which is 0 to pi. And finally, the inverse cosine of the cosine of x is not equal to x for all x, which again we'll just say outside this interval, belonging to real numbers. Take away those real numbers between 0 and pi, including 0 to pi. Alright, and to wrap off this board, let's go ahead and look at the sign of the inverse cosine of 0. See that we've already computed the inverse cosine of 0. The inverse cosine of 0 is pi halves, so I'm looking at the sign of pi halves. And the sign of pi halves is the y-coordinate corresponding to the terminal point of corresponding to pi halves, which would just be 1. So we can say here the sign of the inverse cosine of 0 is 1.